All right. Good afternoon, everybody. My name is Mark Vangeloff. Welcome to an introduction to blockchain and enterprise applications. I'm a graduate of Miami, class of 2012, from the business school with a degree in management information systems, and I was also a member of the Alpha Delta Phi fraternity. I've been working at EY ever since I graduated. I started my career in our IT audit practice and have worked in several other practices like enterprise risk, third-party risk management, before most recently joining our technology consulting practice, specifically focused on digital and emerging technologies like blockchain. So happy to be here broadcasting live from Columbus, Ohio, from our Red Hawks room at the EY office. And with that, I'll turn it over to my colleague Yaniv to give a quick intro for himself.
Hi, everybody. My name is Yaniv Sofer. I'm a manager here at EY and a tech lead specifically in the blockchain practice. So I help our clients both build and launch blockchain solutions in production. And I'll be walking you through some of those use cases a little bit later in the presentation. Before EY, I founded actually one of the first cryptocurrency exchanges back in 2012 in the US, which we ended up selling in 2014. I've been involved in the cryptocurrency and blockchain ecosystem for quite some time, and joined EY in 2019. And actually one really cool opportunity I've had through working with EY and getting connected to the University of Utah. I'm also now an adjunct professor at the University of Utah, teaching a graduate course on blockchain for business applications. And so again, it's all about taking the technology and making it practical. At least that's what I personally am interested in and what I've been working on. So I'm excited and look forward to sharing some of that insight with you today.
All right. Thank you, Yaniv. So without further ado, our agenda for today, we're going to cover off on a few topics. So first, we'll talk about, why everyone is talking about blockchain. Second, I'll do my best to answer the question, what is blockchain and how does it work in under 10 minutes or so? Then I'll flip it over to Yaniv, who will give you some background on how EY is approaching blockchain. And then we'll talk through those case studies that Yaniv just mentioned. And then towards the end, we will address Q&A time permitting. But I would also like to say, if you have questions during the course of the presentation, feel free to pop them into the chat, and we'll do our best to answer throughout the presentation. So why is everybody talking about blockchain and why is it important? Well, to answer that question, it's really important to understand, how the internet as we know it currently works. This is what gives you a frame of reference to understand why blockchain technology is so important. And so if you really boil the internet down to a couple basic components, you get two things, right? You get physical infrastructure, consisting of fiber optic cables, as you can see from the map on the slide, constructed across oceans, over mountains, underground, basically all over the world. This infrastructure is, subsidized by companies like Google as part of their business model. And then kind of working in tandem and sitting on top of that physical infrastructure, you have devices like servers, routers, that help direct communications across the internet. The second component we have are protocols, right? And protocols are just systems of rules that determine how an activity is conducted. And there are real life protocols, right? They exist in everyday life. Consider the photo here on the right. Traffic lights, right-of-way laws, traffic laws in general are examples of protocols that kind of determine how individuals should drive, from point A to point B. And as the picture shows, the absence of protocols, you're essentially left with chaos. So thinking about protocols and infrastructure from the perspective of the internet, protocols basically define the rules in which data is communicated from, point A to point B. These protocols provide the instructions that bits of data need to follow in order to be communicated from point A to point B, like over the internet. And these protocols dictate, how data is organized, how it's addressed, how it's transmitted, routed, and received as it travels across the internet. So, the simple, simplified version of the internet stack here. I kind of like this visual, right? One, because it's simple. I like simple visuals. But it also kind of shows logically how the lower layers of the internet, become increasingly abstract. So the vast majority of internet users are never really going to interact with anything lower than that application layer. So if we start at the top with "you are here," this layer represents all of us currently sitting in front of our computer listening to this session. And if you were to open up your Google Chrome browser, type in mail.google.com, hit enter, you would then be interacting with the application layer. And if you were then to send an email using your Gmail account, you would then be invoking a lower layer that consists of the more use case specific protocols like HTTP, FTP, and SMTP. And if we continue using the email example, right? SMTP stands for Simple Mail Transfer Protocol, and it's a universal protocol that is what enables communications via email over the internet. And since a protocol, right, is just a standard set of instructions, all email applications that use SMTP are going to have, a to line, a from line, a CC line, subject line, body, et cetera, et cetera. And that standardization is the reason that you can send an email from your Gmail account to your Hotmail account quickly and efficiently, right? It promotes interoperability of these applications. And as we continue lower and arrive at the TCP IP layer, TCP stands for Transmission Control Protocol, IP stands for Internet Protocol. This is a layer that's a much more generic set of instructions and protocols that standardizes the way in which computers initiate the connection, which enables the communications back and forth with each other. So at a high level, you can think about it almost like how if TCP acts like the technology that makes your cell phone ring, IP is basically your unique phone number. And under all of that, as I kind of mentioned previously, sits this physical infrastructure, the fiber optic cables that support all of this. You get the idea. So now this is where things start to get interesting, because the internet, as we know it, it's colloquially referred to as the internet of content, because it's optimized to take data, replicate that data, and disseminate it over large distances to, as many people as possible. The internet of content, is capable of supporting 40,000 Google searches every second, 3 million emails every second. So it's powerful, but it's also constrained. And here's why. Consider like when you type a query into Google, what is actually happening. So once you hit enter, query is going to be routed to a centralized database. It's going to interpret what you're asking, find the answer, copy that data and that answer, and return it to you. The internet of content is hyper efficient at doing that, of doing that with certain types of data, right? Text data, files, images, audio, video, right? What the internet of content can't do is transfer value, because it can't preserve transactional scarcity, because it really only knows how to copy and paste. And that's kind of the reason that, financially related transactions that are, meant to transfer value require, a trusted third-party intermediary to facilitate that. So what has happened, in the last decade, and how does this relate to blockchain? Well, in the last decade, the foundation for an internet native financial system has basically been developed. Blockchain presents a solution to the internet's problem of not being able to preserve the scarcity of digital things. So if we take Bitcoin, for example, Bitcoin does two things. The Bitcoin network does two things really, really well, right? It tracks total supply and it tracks ownership. So thinking about Bitcoin within that context, you can kind of start to make the argument that it's nothing more than a native accounting system for the internet. However, the Bitcoin network is only able to track one asset, right? Bitcoin. So from 2008 until 2016, in order to track a new asset digitally, you would have needed to create your own blockchain, which, was a huge barrier to entry. So enter the Ethereum network around 2016. And what Ethereum managed to accomplish was the deployment of a permissionless blockchain network that was robust enough to support multiple different types of digital assets. And this was accomplished, through the development of a standard way to represent assets on the blockchain. And these standards are what are known as ERC20 and ERC721 token standards. So much like that SMTP example from before, we now have, a standard that sets forth the minimum requirements that a digital asset or token must have in order to successfully interact on the Ethereum network. So now, we have a blockchain network that acts as that digital ledger of account with a robust enough framework that it can, deploy and track multiple different types of assets that do, different things. So naturally, after the release of those standards, there was an explosion of development on the Ethereum network. The number of digital assets increased from 572 to over 200,000 in the 3 years following Ethereum's release. And 95% of those were deployed using the ERC20 standard. So to bring, all of this full circle, right? We have an existing internet infrastructure that has standardized the way in which endpoints communicate through physical infrastructure and protocols like TCP/IP. And then, sorry about that. Now we have decentralized blockchain networks like Ethereum that standardize the way participants can communicate and can preserve that transactional scarcity by acting in that digital accounting role. These networks, Ethereum, Bitcoin, what have you, piggyback off of that existing infrastructure of the internet as we know it, and inherit, many of the properties of it, right? It's global, permissionless, available 24/7, et cetera, et cetera. So now having that standard way to develop and deploy multiple types of digital assets in the form of ERC20 tokens on the Ethereum network, it's really given rise and provided the foundation for a lot of use case specific protocols, like things like decentralized finance, which has been the hot topic of the past year and a half. But also there are a lot of implications and use cases as it relates to traditional organizations within things like the supply chain. And ultimately, what we've created is an internet of value that operates in parallel with the internet of content.
Yeah, so Mark, while you go into what is blockchain, how does it work?
I'm sorry, Yaniv, you cut off a little bit there.
Oh, can you hear me?
Yeah, go ahead.
So one of the questions was just what is required to fork a blockchain. So as you go into the next section, I think it's a good opportunity to mention that.
Okay. So now you're probably thinking, wow, this is amazing, but I still really don't understand what is going on under the hood of a blockchain network that really allows this to happen. And, when we think about blockchain, it primarily consists of three components: a distributed ledger, a consensus mechanism, and what are known as smart contracts. So first, as I mentioned earlier, a blockchain is really just a distributed ledger that records transactions on a peer-to-peer network. It's write once and append only architecture. So much like double entry accounting, a transaction can really only be reversed by creating a new transaction. And so transactions are batched together in what are called blocks, and participants essentially compete with one another for the right to add their block of transactions to the ledger. So I like to think of this as kind of a shared Google spreadsheet that is shared between you and thousands of strangers, and anyone can join and make changes to it, except that there are some constraints with, how things are actually added to that spreadsheet, right? So the way in which changes are facilitated, right? Adding blocks to that chain, the block has to be linked mathematically to the prior block using cryptographic hashing and a timestamp. This ensures that the ledger is immutable and tamper-proof. And if you aren't familiar with the concept of cryptographic hashing, the elevator pitch is that it's a mathematical algorithm that maps data of an arbitrary size, it could be any number of bits, to a string of data that's essentially unique and is a fixed size. And the key feature here, and why it's critical to this aspect of a blockchain, is that even the slightest alteration of the original data will produce a completely different and unique hash value string. So relating back to my original comment, by linking blocks of transactions together using this hash encryption, any change to a historical transaction in the ledger is going to cause a cascade of changes to the hash output for each subsequent block built on top, causing your ledger to fall out of sync with the network and expose evidence of potential tampering. Furthermore, in order for your block of transactions to actually be recorded in the global state of the ledger, all participants must agree on the validity of the transactions based on a predefined set of rules that are embedded in the code of the network itself. And this is the concept of our second component, which is the consensus mechanism. And a consensus mechanism is nothing more than a way to get a group of decentralized people to agree on state changes to the ledger itself. So essentially, the consensus mechanism allows all of the individuals who are participating in that shared Google document to agree on a globally defined state. There are a handful of consensus mechanisms out there today, probably the most prominent being proof of work. And they involve multiple parties working in parallel to solve a mathematical puzzle. The key here is that this puzzle is incredibly resource intensive to solve, but easy for others to verify. And consensus is then reached once a single participant has solved the puzzle and the other members of the network have verified their work is in fact correct. The participant, go ahead, Yaniv.
So maybe just one analogy that helped me understand of, the hard to solve, easy to validate. For those of you who have done a Sudoku, right? In order for you to fill in the boxes might take 30, 40, 50 minutes, depending on the level of difficulty, right? But a verifier can look at it, and in fact, a computer software can verify something like that rather instantaneously, right? Do you have numbers overlapping 1 through 9 in the boxes, rows, and columns? And so we're using sort of a function like that is a good analogy, without getting too deep into the tech, what we're looking to do, something that's hard to solve but easy to validate.
Yeah, that's a great analogy. So once that the answer, the proof of work essentially has been submitted to the network, and everybody agrees that it is appropriate and valid, the individual who submitted that proof is granted the ability to append their block of transactions to the ledger, and from there the cycle starts again from this agreed upon state. So thinking back to the question about forking and what's required to fork a blockchain, essentially you are taking the verifiers, the people that are working on that puzzle, and you are moving the work that they're doing to a new global state of transactions, aside from the one that was verified previously. I don't know, Yaniv, if there's an easier way to explain that without really getting into it.
Not really. Maybe the network rewards you for helping keep everybody aligned.
Yeah.
Right, because that's the whole purpose of consensus, to keep all the participants in the distributed ledger agreeing on the same single source of truth.
Yeah, and in the case of the miners, they are incentivized to do this because they are rewarded for being given the opportunity to add those transactions to the blockchain. So the third component I'll talk a little bit about are what are called smart contracts. Smart contracts are just programs that can govern when and how transactions on the network are processed, or value is essentially transferred. It does this by embedding business logic into the smart contract, into the code of the smart contract itself. And smart contracts in essence can act like a store of value, similar to that of like an escrow, right? If a certain requirement or input is received, the transaction is either executed or reverted. And this is I think a really important part for the rest of the presentation, because of the implications that smart contract functionality has with regards to business transactions, and the discussion on implications to the organization.
Yes.
Yeah, go ahead.
The smart contracts basically become like a business logic layer on top of the funds, the ledger system to transact and move funds, right? You can add business logic, and the beauty of it is that it can be arbitrary, right? Anybody who can imagine code, right? That a lot of these distributed ledgers, these blockchains, are Turing complete, meaning you can run pretty much anything you can run in a traditional application or traditional software.
Yeah, from an organizational and business perspective, right? We now have a platform for sharing data and business logic between external parties in a trusted manner. And one of the big implications here in doing so is we've essentially gained the ability to reconcile business to business transactions in near real time. So the last slide I will take you through, and then I will stop talking and turn it over to Yaniv. I just want to talk through, visually what the life cycle of a transaction on a network looks like, kind of in a generic sense, right? And it all starts with, an individual broadcasting their intent to transfer some amount of a digital asset to someone else in the network. So I would say I want to send 5 Bitcoin to Yaniv. And nodes who are, essentially just participants in the network, they're constantly listening to the traffic on the network for these transactions. And they acknowledge the receipt of these transactions by running a series of checks to ensure that the transaction is valid. So we think back to our example of protocols, right? The nodes are essentially checking that a transaction is structured in such a way that it meets all of these requirements in order for the communication to be successful. If a transaction fails these requirements, it is then, it fails or is reverted. So like an example would be, the network will check that the sender address does indeed have access to the required amount of funds that they intend to send to the receiving party. So once, all of these checks are done and the transaction is verified by the network, they get sent to basically a common pool of verified transactions, referred to as a memory pool. And these transactions are essentially bundled into blocks by what are called miners. And miners are a subset of participants in the network, and they are the ones that are actively competing to solve that puzzle that we were discussing earlier. So if a miner selects your transaction to include in their block, and they solve the puzzle first, they submit their proof to the other miners, everyone agrees, that block with your transaction is then appended to the ledger, and for all intents and purposes becomes immutable. And really it's at that point which the funds that you intended to send are moved from, the originating wallet to the receiving wallet. And then the cycle starts all over again from that global state. So that's kind of the end of my sections. Yaniv, were there any questions in the chat you think we should cover before moving on?
I think what is required to fork a blockchain. We could talk a little bit about a fork with all this context that we now had. And then there was another context question around NFTs, and I think it'll make sense with one of the use cases that I run through.
Okay.
So
I touched on the
if you'd
fork,
like,
but if you have anything else to, add in.
I mean, it really boils down to we have a bunch of people who maintain their own copy of the ledger. And we have a different set of rules, right? The consensus mechanism, the rules to how we make updates to the ledger and keep everybody in sync. Should at any point, I'll note that there's 2 types of forks. There's soft forks and hard forks. Soft forks are backwards compatible, meaning you can choose to make the change, but it won't be an issue. You can still participate in the network as a whole. And hard forks, meaning we've reached an impasse as a mining or as a network, a community of nodes. Some of us want to do things one way, right? Some of us say we want to add transactions to the network every 5 minutes. Some of us want to do it every 15 minutes, right? The block time, something like that, right? Would cause a split, and you would split the network, and you would have those who want to stay on 15 minutes, or I guess in the case of Bitcoin, it's 10 minutes, and those who would want to, cut the block time in half, or maybe some people want to increase the mining rewards and things like that. And what'll end up happening is effectively the network participants will vote by deciding which nodes they're going to keep running on which version, on the current or the new version. So one example coming up now would be Ethereum 2.0. Some people may choose to not switch to the proof of stake consensus. They're looking to change the consensus. And some miners may, or some network participants, some node operators might say, you know what, I want to stay on proof of work. And that could potentially cause a hard fork. And there's some contingencies and things the community is doing to prepare for that.
Yeah. So basically, both networks will ultimately still exist. They have just split to the point where um, transactions can either continue to flow the original way or abide by the new rules.
Yeah. And so maybe with that, Amy had a question. Do you see a solution to the amount of electricity and resources that blockchain requires? If you'd like, Mark, you could take the first stab and I'll chime in, or I can just respond. Up to you.
Do you see a solution? I think the easiest answer there is an alternative forms of consensus. Proof of stake being, I think, the prime example, right? Because instead of exerting an extreme amount of electricity and resources to solve that puzzle, you are essentially staking your own funds as a means to provide security to the network.
Yeah, and what I will add is instead of mining being a race, the blocks are assigned based on the proportion of what you've staked. So in mining, if you submit an invalid block, you just don't get the reward, right? And it's proof of work rather, not in mining. You just don't get the reward, and so you're disincentivized that way. You have nothing to gain. In proof of stake, you actually have other validators, is what they're called. They're no longer miners, they're validators checking your work. And should you have submitted an invalid block, you could slash your stake. What that means is you would lose 50% of the collateral that you put up for the right to add blocks and transactions to the network. So I trust you in this case, not because game theory and I believe that, and I verified that you did the work and I know that you're investing the hardware. I trust you because I know that you have a lot to lose and it's going to be costly for you to defraud the network. So the more stake you have, the more blocks you get, because the more, again, going back to game theory, the more you are incentivized to submit a correct block because you don't want to lose your stake. You stand more to lose from a false block than you do to gain from that false block because of the stake mechanism. And so what ends up happening is from an energy consumption perspective, there's only one is doing that only one miner is solving that cryptographic puzzle at a time, or only one validator. And then one other thing that I personally like to add is it turns out that mining or proof of work, Bitcoin mining, I'll just use that as the sort of stereotypical example, is so energy conscious, cost conscious, because the margins are so small that they tend to use renewable energies out of necessity. And it's actually, a lot of these mining operations are very green for that reason. They also move to some of these low electricity cost areas, but largely they tend to be clean because it's cheaper for you to use solar than it is for you to use some of these more traditional sources of energy. Cool, and I think with that, we can move on to the next portion of the presentation. So how is EY approaching blockchain? And I'll start with our vision. So blockchains will do for business ecosystems what ERP or enterprise resource planning systems did for the single enterprise. So ERP systems, for those of you who aren't familiar with the acronym, think like Oracle or SAP systems. And let me backtrack as to what ERPs did for the single enterprise, and then we'll draw the analogy for the blockchain. So in a single enterprise, in the 80s, 1980s, we had digital systems, but and different business functions who were siloed. So you had your think of a factory, right, that you need to plan for your production capacity. So you have your sales folks getting orders in, right? Then you have your ordering, your procurement folks getting the raw materials for you to create your widgets. Then you have your manufacturing supply chain or manufacturing step where you have to turn those raw materials into the actual materials. You have your shipping department and warehousing and all the steps in between to get to the customers, and then ultimately you have your invoicing. So at those times, before the systems spoke to each other through a single ERP system, they typically had disparate systems to manage all these different pieces of data. And so your executive board meetings would be things like sharing data on your upcoming sales forecast or your manufacturing capacity and your manufacturing pipeline and what it's able to do. Things like logistics disruptions and fulfilling orders and maybe needing to expand warehousing capacity. All these things were communicated, so they were more update sessions pre-ERP days because you needed to get the executive team aligned. With the innovation of the ERP, we started to bring all of these disparate functions into a single system. So you're actually able to track within the four walls of the organization. If you're in manufacturing, you're able to see what you have in inventory and actually alert procurement. Hey, I'm lacking raw materials. Maybe something happened and you need some additional materials. You're able to communicate it that way. Or maybe sales orders are coming in and procurement now has greater lead times to get the materials. Maybe you need another supplier because your current supplier can't keep up with the load. Downstream, right, inventory management and shipping and logistics, if you're doing international execution, it could become potentially problematic as things get locked up in customs and meeting deadlines, contractual deadlines, that is, to deliver materials exactly when they need to be delivered. So with the ERP within the four walls of the organization, you now start to have visibility to what's happening before your step and what's happening sort of after your step in the supply chain process within your organization. So really what the ERP did is it broke the four walls of the organization and allowed these meetings to talk more strategy and business execution and focus and take a step back from updating each other because they already have visibility as to what's happening before and after, and focus on more strategic decisions. Again, how do we grow the enterprise? How do we expand to other areas and things of that nature? So that's what it allowed the executive committee to do, but also within the organization, increase efficiency. So what we see is that blockchains, for the first time, are allowing you to break those walls between organizations within an ecosystem. So today, in order to, in our increasingly interconnected world, we rarely see, a single enterprise. Think Ford back in the day, right, doing vertical integration, where they're able to take steel. Steel comes in one side, or even raw ore comes in one side, and you have a car leaving on the other side. Very rarely happens within the four walls of organization. If you look at the Foxconn plant for Apple in Shenzhen, they are a purely assembly plant. They have all the chips, all the glass, all the components to make an iPhone come into Shenzhen, and all they do is construct the iPhone, assemble, package it, and move it on to the next step. And so in that regard, it is incredibly important for you to be able to communicate with your other partners in your ecosystem. I need to know that I have enough chips, that I have enough glass, that I have enough packaging, because it's coming from all these different sources. And so using a blockchain, we're able to provide a single source of truth and visibility to across organizations beyond the four walls, which is what ERP did within the four walls. So let's continue to the next slide, please. And I'd like to talk about some of the value that we see for business ecosystems. So one, as we mentioned, increased transparency across multiple participants. So once you're able to see what's happening, right, instead of having to ask a question and get a report, which can be delayed 30, 45, 60 days, you're getting closer to near real-time data. Eliminating manual reconciliations. I mean, reconciliations happen when I don't agree with Mark as two different business entities. But if there's a single source of truth, a single ledger we're transacting on, we can't be out of sync. And we see a lot of efficiencies in eliminating manual reconciliations and back and forth. A lot of issues we call fat fingering, right, where somebody may have added a zero because they typed poorly on a keyboard doing manual data entry, can be eliminated. Automated contract execution, audits, and reporting. As we talked about smart contracts, we can actually have complete coverage of an audit or of a control. Instead of an auditor coming in and saying, yeah, we checked that, we checked 100 samples, all 100 samples were packaged correctly, or all 100 financial transactions were executed correctly. We can actually say, we don't have to take a sample size. We can actually, on the blockchain, add this business logic for these controls and ensure that all transactions, one, have to follow the controls, that they're accurate financial transactions, and two, alert immediately on any deviations. And so I think 4, 5, and 6 kind of go together with some of the other points I mentioned. So I'll focus maybe on 6 and say that with a blockchain, it's not a one-size-fits-all solution, but you are able to integrate siloed systems and processes into a single environment, which is what the ERP did, and that's really where that statement is coming from. If you don't have anything to add here, Mark, I think we can move forward to how we at EY really assess a blockchain use case and determine whether it has merit or we're creating real value. So as I said, blockchain is not a one-size-fits-all solution. And so if you recall Mark's overview of the components of a blockchain, it's distributed ledger is the first thing that we said. And a distributed ledger means we need multiple parties and multiple points of verification to keep trust. And so the first question, and the obvious one, is, are there multiple parties in the ecosystem? A one participant blockchain is not only, it's not especially secure because there's no sharing and checks and balances, but blockchains are also not ideal for querying, so it becomes a really bad database. From a technical perspective, it becomes a slow database. And so in that regard, if there are not multiple participants in the ecosystem, and they don't necessarily have to be between organizations, we've actually found that there's some international companies that have different subsidiaries across the globe, and we could actually get some benefits there for multiple parties. So they don't necessarily need to be external parties, but we definitely need multiple parties to find value in a blockchain solution. The next question we ask is establishing trust between parties in issue. So because we have this distributed ledger, there's multiple points of verification of the data, and we can trust the technology using the consensus mechanism to make sure that all updates to the ledger meet the pre-agreed upon rules. And you could define and engineer, and there's multiple consensus mechanisms you can choose. So what you've done is you've decentralized control. So if Mark and I decide we need to share data in some way, I could host it, Mark can host it, or we could use a blockchain where we both have a piece of it and we're keeping each other in check. Now, multiply that exponentially to 20, 30, hundreds of participants, and you see where you're able to change the trust model from a network operator or a central entity to the network as a whole, and each participant is now responsible for maintaining the consensus and maintaining the integrity of the ledger. And the third question is around the tamper-proof permanent record of transactions. And blockchains are append only. You can only add data to the blockchain. And if you need to do any reconciliations or any updates, so say I made a mistake and I sent 100 coins when I meant to send 10, I would actually need to ask the counterparty, let's just keep using Mark, he would actually need to send me 90 Bitcoins back, and that's how we would end with a net 10 sent over. And so not only is it important in cases where you need an audit trail to know exactly how things happened, and if mistakes were made, to be able to pinpoint exactly when the mistake was made and how it was corrected. It is also valuable in places where there might be a ton of fraud as well, and think of use cases like certificate of origin and things like that. Are we securing ownership or management of a finite resource? That one should have been quite obvious, and when we talked about the challenges of the internet. Right, is that blockchains are really, really good at maintaining scarcity. And so if you have a need for scarcity, this is incredibly valuable. And lastly is, does the ecosystem benefit from improved transparency? And it goes a little bit hand in hand with trust, but the transparency is, when we were talking about smart contracts, Mark mentioned, we want to make sure that all participants are following the same process or the same business logic. And we can do that by using something like a smart contract to create transparency to how a calculation was made, or to create transparency again on the origins of certain things. So I think we can move on to some use cases. I'm looking at the questions. How does one scale a world node base? Sorry, 1 second. I'm reading a question. Okay, I think some of the answers I'd like to focus on maybe the slides and the use cases, and I think some of the answers will automatically be answered just by virtue of going through these use cases. So this is a case study of public finance manager. And so if we go to the next slide, the IFAD was the client we worked with, and they are the International Fund for Agriculture Development. And what they do is they receive donations for earmarked for development of third world countries or growing developing economies, and help them develop agriculturally with the mission of developing agriculturally. And they're doing quite a large number, both in quantity, the number of transactions, and also the size of the transactions, the amount of money that they're distributing annually to these nations, to these economies. And so the problem here was that IFAD was having some challenges tracing and identifying how the funds that they have distributed have been used. And in particular, it's important both for the donors, for them to be able to create trust that they're spending the funds in a responsible way, but it's also important for IFAD also to help them understand how funds are being spent, what they're getting for it, and at any given moment to be able to start to evaluate and optimize. And so, as you can see here, the bolded words, right? The proof of concept was really to enable IFAD's mission to deliver trust through transparency. And some of the advantages of using a blockchain in this case, we're starting with the immutable record, which is important because they can provide a tamper-proof log of transactions to their investors and create trust that way. Automated controls were important to make sure that you're preventing, sanctions and anti-money laundering concerns that they have. Again, we're talking about these developing nations. If you give, $10 million to Kenya, how do you know it's going to farmland development and agricultural development and not the warlord or whoever may be, running the country? We're able to get some proactive monitoring for anomalous activities, but also I think proactive monitoring has also been very good for us in identifying opportunities. So maybe certain budgets haven't been spent, or certain budgets are on track to go overboard, and it allows you to make real-time decisions before a financial period is over, and then reshuffle the distribution of funds. And then streamlined verification, I think that's pretty straightforward. So I'll focus on the outcomes-based metrics, where we're actually able to use the blockchain to not only record how the funds are being distributed, but to record the impact of the funds. So really with the solution that we created, it's called PFM, Public Finance Manager. The specific use case is for IFAD. So PFM aims to answer 3 questions. Where have I allocated my money, right? So where is it supposed to go? 2 is at any given moment be able to tell how has my money been spent to date. So if you've allocated $1 million, how much of that has been spent to date? What do I have left? And get metrics that way. And the 3rd question that we're now able to answer using PFM is, what did I get for the spend? And so if we go to the next slide, I'll walk through some of the flow of funds and why it's so challenging for an organization like IFAD. So looking on the left-hand side, we're starting with the donors. Funds go over $1 billion a year in donations coming to IFAD. And those funds go out to the borrowers and implementing agencies, and ultimately end up with the suppliers and beneficiaries. Now, if you look at IFAD and the direct arrows that come in and out of it, you can see that it should be clear to IFAD how much money is coming in, and it should be clear at a high level where it's going out. The problem is that this is a simplified diagram, and over on the right where we see that, crisscrossing pattern, there's multiple steps in between. It's not a direct one-to-one. So think of IFAD earmarking funds to, and specifically the POC was for the government of Kenya, so I'll keep using them as an example. So it's going to the government of Kenya, then it's being earmarked to the Ministry of Agriculture, and then the Ministry of Agriculture is talking to different suppliers who may in turn use other suppliers and beneficiaries, because they go to the Ministry of Agriculture will go and distribute the funds to the north and the south regions, and then their governments will go ahead and distribute. And you could see quickly how complex something like this gets. So for IFAD, at any given moment, to get these reports is incredibly challenging. Not to mention that because these are developing nations, the folks on the right-hand side, the suppliers and beneficiaries, and really everyone beyond IFAD, is not necessarily as technologically advanced as a corporation, a Fortune 500 corporation might be, right? They might be using 3G cell phones for their internet connectivity instead of what we see as like gigabit internet connections and things like that. They might even use pen and paper to track their ledgers in some of these places. So it's incredibly challenging. But ultimately, what we were hoping and the value we were hoping to create is to provide transparency, understand the flow of funds, and then even provide downstream value as well. Say, IFAD is working with the government of Kenya and they're giving to the Ministry of Agriculture. Again, they could audit internally without looking to IFAD to give them transparency. And I think with that, I'd like to talk about some of the infrastructure challenges. So if we go to the next slide, talking about blockchains, one of the biggest challenges that we see in enterprise blockchain applications is how do you get the data into the blockchain? You definitely don't want to duplicate it, because now you have to reconcile something. And that could potentially cause errors, right? If I have to copy everything out of one system into the blockchain system, what is the real value there? And so we set out in this proof of concept to ensure that we were able to integrate with existing systems and processes and have the blockchain as sort of a data layer acting in the background rather than a new system that will take over what's currently being used. And so the obvious one is we're integrating with IFAD's current systems, reporting systems, and frameworks, so what they were using there. For their processes, we took some controls that they have over the funds, things that we mentioned like the sanctions checks that we need to do in anti-money laundering. Those are also being encoded. From a donor perspective, we are able to give more clarity to the donors, so their donation platform, to give clarity on how the funds are being spent, and ultimately downstream accountability by creating these simple web portals that allow these individuals to connect either from a browser or a mobile device to interact with the IFAD system. And so in a lot of places, we've actually also provided the downstream users of this platform a better way for them to manage their own processes and their own funds. And so if we keep going to the next slide, so in this end-to-end application, this is just a view of what we did. So if you look at this slide, I'm sorry it's a bit small. So on the bottom right, you actually have a block. I think it's $103 million disbursement, or even sometimes these things are even loaned from IFAD, so they need to be repaid, but to the government of Kenya. And you can see how complicated these get. And in fact, there's some other steps beyond those three buckets that you see. But for the first time, we're able to get this visual that would take 6 months after the fact to compile. On the IFAD administrator view, you can't read those alerts, but some of the things that we're saying that we're able to now alert them is we're approaching the end of the quarter. Think of reallocating funds. Here's an alert or an insight that a certain group was under budget or over budget, and you may need to plan accordingly. And now they're able to go to their donor base, get additional funding. Maybe they're able to investigate and reach out to the recipients, the initial recipients, and ensure that they're allocating capital appropriately. And so I think the last slide is on the PFM overview, but I think I've talked quite a bit about this solution. So let's maybe walk into the other use case. I want to make sure we have enough time to talk about all three. So Birra Peroni is an Italian beer company, if you ever had a Peroni lager. And so here are some quick facts about them. So specifically, what I want to focus on is those last few bullets where they have quite a few farmers and hectares of land, tons of barley each harvested each year, and their 10-year mission to increase production capacity while respecting environmental performance. And so we're able to, adhering to some of the requirements here, right, to prove that there's over 100% Italian malt, right, that there's 100% Italian malt, that they don't use malt from other regions, to prove the origin, but also the sustainability of their business. So if we go to the next slide, we'll talk about what we did. We created a solution to allow end customers the ability to gain visibility into where their beer came from. So imagine being at a supermarket, scanning a QR code on your Peroni beer, and being able to see exactly where it came from every step of the way. And we've used a blockchain to create wide access, to provide transparency, and to create this immutable audit trail that allows anybody to verify the integrity of the data that they're seeing. And so if we, these are just some of the phases. If we go to the next slide, there's a video of the app actually in flight. And I believe it's playing, so this is great. And so we're looking at you're logging in, great. You're seeing some information. You're able to choose your beer and enter a code that's on the bottle, or conversely, you could also scan a QR code that'll be on the bottle. And we start our journey with the farmers. And what we're seeing here is the commitment to 100% Italian ingredients, really, and Italian farmers. And we're also able to see for a specific harvest some information about what happened that year. And as you see here, we're actually seeing the blockchain certificate that we have encoded with the verifiable data. And this is some of the things that we're looking at, so you can see for a specific batch of beer what region that barley came from, and you could see what year that barley was harvested, and from the farming perspective. The next step is the malt house, where we actually malt the barley, and that's what goes into your beer to give it that unique flavor, and that's where we extract some of the sugars. And so we're, again, starting with the provenance from a supply chain traceability, giving you visibility as to where it came from, moving into the brewery, right? What happened, how long it was fermented, the pasteurization information, etc. And I think we could move on to the next slide, and ultimately be able to see the entire life cycle and how this beer got to you. So what I want to take a moment to mention is that what we've really accomplished is we've tokenized batches of beer and put them on a blockchain. So this is these are a collection of non-fungible tokens that we have represented on a blockchain, on the public Ethereum blockchain for this use case. We have then recorded all of the different instances and different events that happen in the life cycle of this token, and ultimately you as the end consumer are able to review it and see that it's verified. And so the benefits that we see, right, is that you're able to tell the value of sustainability. You're offering your customers some access to data and some assurances. we find this is incredibly valuable. Things like this are incredibly valuable for sustainable organics. So certifying the origin of your materials organic. And I believe we had a question on NFTs, right? And you want to tether it to paper or something physical in the world. How would you do that? It's really through this process of integrating the NFT process either deeply into the supply chain or through trusted sources. So we've done this for wine as well. So turns out two of the most counterfeit things in the world are pharmaceuticals and wine, because it's really easy for you to, grab an old bottle, print a label at home, and pour some red liquid in it, cork it, and call it, a 10,000-year-old or $10,000 bottle of wine. It doesn't even have to be that expensive. You could take your $10 bottle and sell it for 80, and I'm pretty sure people would drink it happily, right? So we're able to, for the first time, create scarcity, right? So that the seller can only sell this bottle of wine once, because as soon as you sell it, that ownership, it's burned, right? It's been sold, so that doesn't exist in inventory. So if you were to scan that barcode, that QR code that they printed on 10 bottles, at that point, all 10 would show that they've been sold. Sorry, all 9 after the first one would show that they've been sold. And so the trust comes from the wine manufacturer and the logistics providers in their supply chain. For something like art or something like that, you would need to have a trusted source is really where we're seeing an oracle of sorts, or maybe a keeper, to say, I don't know, you deposited it with whatever entity is able to safeguard. Let's just take the Mona Lisa, right? It's physically at the Louvre. They go ahead and they issue a token because you trust that they're holding this art, and they're now able to give you fractional ownership, right? Let's say they make 1,000 shares of the Mona Lisa, right? The trust comes from the fact that you know that they have the physical painting, and if you buy all 10,000 pieces, or sorry, all 1,000 pieces, you can go to the Louvre and claim your physical asset, right? So it's really hard to maintain that link. And we find that IoT devices are actually pretty crucial. And what we currently see as trusted sources, so think large entities, or maybe even your bank, to ensure that you have money in a safe when you issue stable coins, right? That's really what they're doing. They're acting as a tokenization agent, providing trust by saying that we're holding the underlying asset. Another great question from Rick is, would a manufacturing situation with multiple independent suppliers use blockchain to track quality and supply issues from raw to finished and assembled product, as well as the financial transactions associated with the manufacturing steps? Absolutely. And so what we find is that in the case of COVID, when traditional supply routes and suppliers were not able to keep up with demand due to disruptions in the supply chain processes, you had these large companies have to onboard additional smaller suppliers, or maybe suppliers they don't normally send certain volumes to, and smaller ones to meet their needs. And so one of the advantages would be if you're able to guarantee that if you're doing an organic product, you can guarantee that things came in organically. That would be huge, right? It would help you trust some of the smaller suppliers that may not have a name brand yet, that are looking to grow, and they could provide you trust in other ways. And so with that, let's look at my third use case here that I plan to present. My third and favorite is the Microsoft Xbox royalties solution that we created, again, for Microsoft Xbox. So today, over on the top right-hand side, that top right yellow box, distribution company, that is where a marketplace operator like the Xbox Live marketplace would sit. You could think of it like as a Sony PlayStation, or the Switch network, where they're actually directly selling games as a marketplace to the consumers. When a video game is sold, Microsoft is the entity that gets the funds. Like when you make a credit card transaction, it goes to Microsoft. They then need to pay royalties and dividends and shares over to the marketing/publishing companies. And a good example is, say, EA Games or Activision or Ubisoft. right? Those are the publishers that get games and publish them on behalf of some of these smaller developer studios and intellectual property, you know, the individuals who are actually building the application or the game. And so when Microsoft gets paid, so let's start on the bottom from sales revenue and work backwards. So sales revenue is paid to Microsoft, right? Then they then go over to the marketing and publishing company, and they need to generate a royalty statement and payment to say, we think we've sold 100,000 games based on our reporting in these regions, these discounts, etc. This is what you should get paid. That is, as you can see, is plus 30 to 45 days for the cash flow. And a lot of that has to do with reconciliation. Again, for the developers and the intellectual property owners, it's another 60 to 75 days for them to get their royalty statements and payments. And really, there's been a lack of trust and transparency in how these calculations are made. There's a lot of black boxes and a lack of clarity, right? Because all you get from Microsoft is you are owed this much in royalties for given months or a given sales cycle, a given period of royalties calculation. Not only that, the manual processes are resource intensive and limit the business's ability to scale. And so what we've done, maybe let's go to the next slide. Let me see. What we've done is, we could follow this, is that we've taken our digital assets and registered on the blockchain, right? So these games, these items that we're ultimately selling, and we're encoding the terms and conditions, these physical real-world agreements that we have created on how royalties should be paid, into smart contracts. So remember, smart contracts were programs that are running on a blockchain that inherit the properties of the blockchain in the sense that they're immutable, they are distributed and run by every participant, and they have to follow the rules of consensus. So we are encoding these contracts and specifically the terms and conditions on how royalties should be calculated on a given sale. And both parties can now review and agree, meaning Microsoft and the publisher can agree this is accurate to the contract that our lawyers negotiated and the terms that they put forth. So once you've done that, the smart contract is immutable and will not change. And so you know every calculation that's going to be made is going to be accurate according to the terms that you reviewed as a publisher and you agreed upon as a publisher. And so these games are now sold, right? Go back to the store or the digital marketplace, and Microsoft has hooked up their sales reporting systems through an API directly into the blockchain. And so now every single sale, as Microsoft gets it, is also reported or input into the blockchain, and it triggers a calculation from the smart contract. And as you could see an example of the distributor, the publisher, and the developer each getting their cut in the royalties statements. And so the participants get instant access. The transactions, again, are monitored and certified because we know we've agreed to the rules, and we've now able to gain additional efficiencies that we weren't, and transparency that wasn't there before. So, you know, going back to our 5 blockchain questions, are there multiple participants? Yes. Is there a lack of transparency? Absolutely, because we don't know exactly how calculations are being made, and now we, for the first time, have visibility. Is there a need for an immutable record? Yes, we want to know exactly what Microsoft or what has been reported to have been sold at any given moment, and show that we're accounting for it all. And so if we go to the next slide, it goes, I believe that's the tech slide. So this is just the tech, and it shows the similar process from a tech perspective, and we used a quorum-based network to onboard them as nodes and participants onto the network. Really what I want to focus is this middle part where the smart contracts are run by Microsoft and their partners and the analytics nodes. So by being a participant on this network, you are also ensuring that the smart contract is run correctly and it's not tampered with. And I'd like to end on the last note here and leave about 5 minutes for questions, is what were the benefits of this for Microsoft? So if we go to the next slide, you know, what we've seen is we've seen about $3 million in daily transaction processing capacity. we were able to reduce the contract setup and the contract onboarding from 2 hours to less than 10 minutes. The publisher's access to earned royalties, right? So the visibility to the statements has gone from 45 days to less than 4 minutes. So can you imagine launching a new game in the market and not knowing how it was selling for 45 days? That's mind-boggling in today's digital world. And so we're able to give them near real-time visibility. And lastly, 45 days to less than 7 days, we're able to allow an increased efficiency in finalizing and closing these royalty statements and actually making payments. And so with that, I'm happy to leave about 5 minutes for questions or turn to you, Mark, for any final words.
Yeah, so I think, we got a few questions that were submitted prior to the session today, and there are a couple, I think, with the time remaining we can cover. And the first one being, what are the top industries that are using or exploring blockchain tech, beyond financial services?
Oh, sorry, was that directed at me?
If you want to take a stab at it first.
Yeah, so what industries do we see for top use cases? So I'll leave the creator economy to you because I know you like that one, Mark. So I'll say, as we talked about, you saw a lot of supply chain use cases today, and that's where enterprises are realizing value, both in tracking funds and tracking funds movement, but also tracking inventory and inventory movement. So really tokenizing their assets and tokenizing their supply chain for traceability. But ultimately, if you think long term, if you're able to now integrate this with things like supply chain financing, things like invoice factoring or borrowing against inventory that you're holding and things like that become much easier with the transparency that blockchains create. We also see use cases in complex business processes. So in the case of Microsoft, the complexity wasn't in calculating a single contract and a single royalties calculations. It was the fact that there's tens of thousands of games, each with their own nuanced calculations and multiple parties involved. And then beyond that, the challenge evolves to, the sheer manual effort that's required to keep track of something like this.
Yeah, and I think I'll just add, there's a lot of activity, I think, around the concept of NFTs, specifically in like things like professional sports. We're seeing a lot of professional sports organizations issue certain types of loyalty and rewards programs through assets that they distribute to their fans. And you have Mark Cuban and the Mavericks organization implementing cryptocurrency payments for things related to that organization as well. And even things like NBA Top Shot, which is a blockchain-based NFT program that essentially is capturing moments from NBA games and creating NFT collections for those, where the owners of those now, essentially own a digitally scarce version of a moment in an NBA game.
Yeah, and one more thing I will add to the creator economy for those of you who may have heard of Stoner Cats or maybe not. This is a cartoon animation show by Mila Kunis, Ashton Kutcher, Seth MacFarlane. And what they did was they minted a non-fungible token to fundraise for the creation of this show. And by holding this token and participating, you're now able to participate in making decisions for future episodes. So what they've done is they basically have allowed you to have a voting say in the content that they're going to create and help people engage with their show. So you see all of these models in the creator economy coming up, or some of these digital art NFTs where folks are now able to sell their art and monetize it and hand over the copyright or the license along with a bearer token, essentially, which is this non-fungible token asset.
Yep. And okay, so with 1 minute left, the last thing we'll end on is a question that says, and I think this goes to one in the chat earlier as well. There's a lack of understanding on the part of the general public about blockchain. And what is EY doing to address some of this? And I really like this question because I think education is paramount, right? Without understanding, how things work underneath the hood, blockchain kind of seems unremarkable. But once that light bulb kind of goes off and you understand why it works and how it works, you understand the implications to, whether it's an individual or an organization using it. And what EY is doing, I would say, things like this. Believe me, we wouldn't be here talking to you if somebody, one of our bosses didn't think it was important. Yaniv is a professor now. He is teaching a blockchain-based course. And lastly, EY and our global leader, a guy by the name of Paul Brody, is very outspoken in public Reddit forums on Ethereum finance, right? We're holding a public meetup for blockchain in New York City coming up. So these are the kind of things that EY is doing. We're trying to not only develop solutions that enable businesses to capitalize in technology, but we're also trying to reach out to, the individuals and those that just want to interact with the technology as well. So
Yeah.
I think that's time, but Yaniv, you want to close us out?
Yeah, I would just say that ultimately, right, as a consumer, you don't need to know exactly how blockchains work to understand some of the value. So, Peroni, right, as a consumer, you don't necessarily need to know how to transact with Ethereum, but you want to be able to verify certain statements. And so a little bit on the education from a consumer perspective, but really from an enterprise perspective, we see blockchains happening on the back end. Right, they're a layer to keep disparate systems in check. They don't need to be on the front end. You don't need to look at hashes. You don't need to, understand how to run nodes necessarily, kind of like how you don't need to understand how the cloud works by using an AWS, right? We're helping you distill the business value that you can get and how to think about the future, given the tools that this technology brings or the new processes that are now being enabled. You don't have to change the way you do business, but you can improve your operations, and that's really where we see blockchains excelling.
All right, I think we are now at time. Thank you, everybody, for joining and listening to us. We hope it was informative. Please reach out if you have any additional questions, and have a great week.
Awesome. Thank you, everyone.